This is lesson 5-4, sum and difference identities. So here are the identities, and you do have them on your formula sheet, and so you need to be careful about how they're written. So you can go find them. You don't have to copy these down. But if you notice, I think in your sheet it starts out with sign first. So if I'm looking at the signs, a way to remember it, because right now you're not going to have to remember them, but you're going to eventually have to remember them. Notice that sign, if you're adding, it's still adding, but the sines and the cosines are mixed. So sine of the first, cosine of the second, cosine of the second, sine of the first. And remember, these are angle measures. These angles can be in degrees or radians. And if you're subtracting, it's subtracting, and the sines and the cosines are mixed up. So you start with sine because it's a sine, and then do cosine, cosine, and then sine. It flips. Now with the cosine one, if you look at it, it puts it as 1. It goes plus minus in the identity, and then over here it goes minus plus, because that's what's mixed up. Sign switches. So if it's a plus, it's minus. If it's a minus, it's a plus. But then the cosine stays together, and then the sine stays together. So the cosines and sines aren't mixed, but the sines are flipped. Just a way to remember. And then here's your tangent. Denominator, well, numerator stays the same 1, and then the denominator switches signs. Notice both of them. And then other than that, everything's the same. It's tangent x, tangent y over 1 minus tan x, tan y. So you're probably thinking, okay, so what? Why does this make any difference? This is why. We want to find the exact value of each expression right here. 75 is not on the unit circle. It's not. So otherwise, I can't find an exact value. But I can if I break this up. So I need to figure out what two numbers that I can add together or subtract to give me a 75. Well, I'm going to start with addition. So this is 45 plus a 30. Maybe it was subtraction. Maybe 90 minus 15, but there's no 15 on the unit circle, so I'm not going to do subtraction with those numbers. It does equal 75, but 15 is not on the unit circle, so I want to stick with this one. So I want to say, I want to use the addition. So cosine addition. So cosine of 45 plus 30. And remember, I'm using these two because those two show up on the unit circle. Right, on the unit circle. So it says it's cosine of the first one times cosine of the second one. And the plus and minus signs are mixed up, so this is a minus. And then it's sine of the first one, sine of the second one. So then you go and you think through your unit circle or grab your unit circle, whatever it is. Cosine of 45, cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. And then minus sine of 45 is square root of 2 over 2. And sine of 30 is a 1/2. So let's move this up a little bit. And just finish this out. So the rest of it's just simplifying. I'm going to multiply this. This is square root of 6 over 2. No, it won't simplify down. Minus, this is just square root of 2 over 2. And then I'll combine it into one fraction. So square root of 6 minus the square root of 2 over 2. And I'm done. You can't go any farther on this because it's like common, like terms. Sorry, not common. Like terms. They're not like because the number under the radical is not. And right here I just messed up because 2 times 2 is not a 2. It is a 4. So these should be 4s right here in the denominator. The same. And so you're done. So we're going to use the tangent this time, and this one is in radians. Now, it might be easier for you to change your radians to degrees and then solve it, because sometimes it's a little easier to see what two numbers added or subtracted will give you the other one with a tangent, or sorry, with degrees instead of radians. So I've just done some ciphering. Okay, yeah. Moving on, what that meant is that I've just figured out what 2 I could use. And this time I'm going to use subtraction. This is 7 pi over 6 minus pi over 4. And really, I just kind of messed around and played with it. You could have done some additions, but I chose not to on this one. Maybe could have, but it could have been either one. So I went ahead and chose subtraction just because the other time I did an addition. Honestly, that's really why I did it. So here are my 2, and it's tangent. So I'm going to use my tangent. So tangent of 7 pi over 6 minus pi over 4. And I know it has to be those 2 because the common denominator of those 2 would be 12 anyway. And then it's subtraction, so I need to keep on the top. So tangent of 7 pi over 6 minus tangent of pi over 4 divided by 1, change the sign to a plus, and then tangent of 7 pi over 6 times tangent, I'm running out of room, pi over 4. So grab your unit circle, memorize your unit circle. 7 pi over 6 is negative 1/2 over negative square root of 3 over 2. Pi over 4 is going to be a 1 because it's square root of 2 over 2 over square root of 2 over 2. Then 1 plus negative 1/2 negative square root of 3 over 2. And then tangent of pi over 4 is 1. So let's just do some reducing here. There we go. Those are gone. This is 1 over square root of 3 minus 1 over 1 plus negative square root of 3. Sorry, erase that. Now we need to figure out how to simplify this fraction. So common denominator in the numerator, minus square root of 3 over square root of 3 over, and then square root of 3 over 3 plus 1 over square root of 3. Move this up. Almost done here. 1 minus the square root of 3 over the square root of 3, and then square root of 3 plus 1 over the square root of 3. This is our main fraction bar. The denominators are the same. They're gone. And then I'm going to go over here. 1 minus the square root of 3 over 1 plus the square root of 3. I could rationalize that denominator. Not really going to. I'm going to stop right there. We could take it farther, but it'll just take more time. So if you wanted to, you would multiply by the conjugate to get the radical out of the bottom. But that's our exact answer. You could also use this to go backwards. So I have no idea what the tangent of 78 degrees is. But let's see. This was a minus. So I know that using my tangent sum and difference formula, that I would go tangent of, that's a minus, it needs to be a minus, 78 minus 18. So that's tangent of 60. And then I grab my unit circle, tangent of 60 is the square root of 3 over 2 over a half. It reduces down to square root of 3. So that's nice, going backwards. And then this one's simplifying. We have all of these values, and all of that's on the unit circle, so I can just plug in the values. So the sine of pi over 3 is the square root of 3 over 2. Cosine of pi over 4 is the square root of 2 over 2. And cosine of pi over 3, a half. Sine of pi over 4, square root of 2 over 2. Just simplifying. Square root of 6 over 2 plus the square root of 2 over 2. That's not over 2. I forgot to multiply the 2's. It's over 4. So square root of 6 plus the square root of 2 over 4. Alright, so this one's kind of fun. We can actually just distribute this into here. And so the cosine of the arc cosine of x, that's just going to be an x. And then arc cosine of the square root of 3 over 2. So remember that has to be in quadrant 1, and we're looking for where that's at. And so where that is actually at pi over 3. So this is pi over 3. And then the cosine of pi over 3 is a half. So it's 1/2 plus x. So when it says verify, you can't use that identity. You have to use a different one. So I want to use the cosine. I need a negative theta. So I'm going to say this is cosine of 0 minus theta and use my sum or my difference formula. So that one is the cosine of 0, cosine of cosine of theta, sorry. And then cosine changes the sign, so that was a minus, so this is a plus. And then it would be sine of 0, sine of theta. So cosine of 0 is 1, and so this is 1 cosine of theta. And sine of 0 is 0, so this is all gone at 0, so it's cosine of theta. So don't use the even odd formula to prove it. You have to use a different one. So that's just how you would do it.